Okay, our last example in this video series, I guess, it's not just one video, there's a couple videos, is finding probabilities of dependent and independent events. So first we have to figure out if they're dependent or independent, and then we'll find their probabilities, okay? Two cards are drawn from a deck of 52. Determine whether the events are independent or dependent, then find the probability. Okay, so letter A, selecting two diamonds when the first card is replaced. So I draw a diamond, or I draw a card, hope it's a diamond, and then I put it back. Does that change the amount of cards that are in the deck if I put it back? No, it doesn't. So both cards, both of the two cards that I pick have an equal chance of being picked. So these two events are independent, and we're going to write an explanation as to why. Independent, since replacement will not affect second selection. Since I'm putting it back, it's not affecting the probability of that second card I pick. So now we're going to figure this out. What's the probability of drawing a diamond, and then I put it back, and then I draw another diamond? So, probability of a diamond given a diamond. So, those are diamonds in case you can't tell. Well, how many diamonds are there in the first place? There's 4 suits. One of them is a diamond. 52 divided by 4 is 13 out of 52. I keep wanting to write 15 for some reason. So 13 out of 52 the first time, then I put it back. The probability is still the same. 13 out of 52. Multiply those together. Let's figure out what our probability is. 13 out of 52 times 13 out of 52. 6.25% chance of picking a diamond and then another diamond after I put the card back. So that's the probability of that happening. All right. Okay, let's do letter B. Selecting 2 diamonds when the first card is not replaced. Are these independent or dependent? Does not putting back that card change the probability of the second draw? Of course it does. So these 2 are dependent. Dependent, and we're going to give an explanation, since there will be fewer cards to choose from. Okay, there'll be fewer cards to choose from. So now that we've decided it's dependent, let's find the probability of getting a diamond and then a diamond when I take away that first card. So diamond given diamond. So what's the probability of getting a diamond the first time? It's the same thing as it is up here. 13 out of 52. I pick a diamond and I leave it out. How many diamonds are left? There's 12. How many cards are left? 51. So I multiply those 2 together. So we have 13 divided by 52 times 12 divided by 51. And then I hit Control Enter, times 100. 5.88% chance of that happening. So 5.88% chance of that happening. Okay, lower chance since it makes sense because if I put the diamond back, there's a higher chance that I'll pick it. But since I took one and I left it out, there's fewer diamonds to pick from, so there's a lower possibility that that could happen. So that makes sense. Whenever you find you're doing these and you ask yourself, does this make sense? Picture it in your head. Okay, because a lot of probability is logic. All right. So finally, letter C, a king is drawn and is not replaced, and then a queen is drawn. So these 2 events, it seems like they're independent, but they're not. It is dependent, even though you're picking different cards, but since it's not replaced, there are fewer cards to choose from, so that makes it dependent. Fewer cards. Okay, so even though the suit or the what's it called? The face value is different, there's still fewer cards that you're picking from because I didn't replace it. So the probability of a king given queen. So how many kings are there in the first place? There are 4 kings out of 52 cards. How many queens are there? 4. Even though I took out a king, there's still 4 queens. But the thing that changes is how many cards are left. Since I took a king, I took a card out. So that means there's only 51 cards now to choose from. So we're going to plug that in and see what the probability of that happening is. So 4 out of 52 times 4 out of 51 times 100. Oops. So that actually is a 0.6% chance of that happening. 0.6% chance that I would pick a king, take it out, leave it out, and then pick a queen. Okay, so those are how you find probabilities of independent and dependent events. So in class, we're going to do number 7, which is all about dependent events. All right, so, or independent events. So I hope this makes a little bit more sense. Like I said, if you have questions, come ask me.